This question is from the 2024 higher level DCG Leaving Cert paper, and it's question C1 on geologic geometry. The accompanying map located on the back page of section A shows ground contours at 5 metre vertical intervals for a white water rafting course. Okay, so we're dealing with 5 metre vertical intervals, that's important. ABCD is the centre line of the course, and O is the centre of a circular curve which forms part of the course edge. So we've ABCD and O there in the middle. The course has the following specifications. The portion from A to C is level at an altitude of 60 metres. Okay, so the circular bit as well. The portion from C to D is falling uniformly at a rate of 1 in 20. So for every 20 metres you go out, it falls 1. Side slopes of 1 in 2 for cutting and 1 in 1.5 for embankment. Complete the earthworks necessary to accommodate the course on its northern side. The earthworks on the southern side have already been completed. Okay, the southern side helps us a little bit because it kind of shows us what needs to be done. Right, I'm going to start off from A to B. We're told that it's level at an altitude of 60. So I can put a dot there. That's going to be a changeover point. 60, I don't see 60 here at this point, so it's not going to go as far as the road. So I'm going to start off with this portion here. The contours here are below 60, so it's going to be fill or embankment. 1 in 1.5 for embankment means 5 because it's 5 metre vertical intervals. Multiplied by 1.5 is 7.5. So the distance between the lines here is going to be 7.5. And they're going to be all parallel with the side of the road because it's a level piece of road. Side of the road must be 60 because it's level at 60, and then if it's fill or embankment, we're going to be going downhill. So 55, 50 and 45. 60's there, that's the 55 line there, 50 and 45. Okay, so that's our first line there found. Now, next we move on to this portion. This is going to be cut. We have a circular bit here, so I'm just going to draw a line from 0 to B, or O to B, and O to C, because that's going to be where the curve stops. Now, this portion here is going to be cut. Side slopes for cutting is 1 and 2, so 5 multiplied by 2 equals 10. So it's going to be 10 mil between these ones. I'll just go as far as that line from O to B. Okay, again we're going to be starting at 60. Now we're cut, so it's going to be going uphill. 65, 70, 75 and 80. So 60 meets there. Next one then is 65. Next one is 70, 75 and 80. What's the next one? Have we one there? I don't know if it goes in any further there yet. Right, circular bit is the same. It's, where are we there? 60 only hits there. So these contours are all above 70, 75. So it's the same. We're going to be cut here as well. So we need to swing them around point O, or 0. Same measurements. That brings us around to that side. Same numbers now, so we ended up at 80. I'll just draw in that there to begin with. Next one here was 75, so we're going back down now again. 75, 70, 65, that's still on 65. Then we're back up to 70 again, and 75. Okay, don't know where 80 goes just yet. So it doesn't just touch the side of the road, that's just the contours of the ground. Now, that's all okay, that's A to C finished. Next part then we have C to D. Now they tell us in the question C to D is falling uniformly at a rate of 1 in 20. So we need to go out now a multiple of 20, whatever's closest to D. So if I go out 10, 100 millimeters, that gives me this point here. And that means if we go out that distance, the level at that point, because it's 1 in 20, will be 5 meters lower than C. So if C is at 60, this one here must be at 55. Because wherever every 20 we go out, it drops 1. If we go out 100, it's going to drop 5. Now, with that in mind, we can work out now our slope. So the first part here, we've a crossover point there. First part in here is going to be cut, because we're still higher up. So cut at the foot, fill at the hill. So our cut cone is going to go at the foot. The foot is the low point, which is this one up here. So the cone's going here, or the circle, semicircle. Now we need to figure out what size it's going to be. So side slopes for cutting is 1 in 2. So that's 2. So 5 is the difference in level. 5 multiplied by 2 is 10. So it's going to be radius 10 up there at that new point that we found. So radius 10 at the side of the road. Okay, that line now is going to join back to this point here at C as a tangent. And then we're going to have lines going up from that. So again, it'll be 10 between them. And the numbers on those will correspond with this. If that's at 60, so the first one has to be 60, then 65, 70, 75 and 80. Now look at the contours. So 80 hits at that point, then we're back down at 75, 70, 65, 60. And I want to get the 55 one as well to know exactly where it hits the side of the road. So I'm going to go in 10 as well from that line, draw another line beneath it. And that one's going to be 55. So 55 meets at that point. So now I have an exact point of where it meets the side of the road. So if I draw that, it's going to start there, go up through those, up to 80 and back down to that point. Now, going the other way, this is a little bit of fill up here at the top. Cut at the foot, fill at the hill. The hill, that's the highest point, so it's going to go down here at the bottom. Radius for it is going to be the difference in levels, so that's 5 multiplied by the embankment slope, which is 1.5, so it's going to be radius 7.5. Let's see. That one, and that's going to go as a tangent to our new point there up at the top. Distance between the contours here will be 7.5, so I can draw them in now as well. 1.5 is there. And they're going to go with the same slope as that one. Now we've lines on top of lines, gets a little bit confusing. We start from here now. 50 is that one. Starts there. 40. 50, sorry, 45 That's that one. 40, 40, 45, 50, and we're back up to 50 there again. Now, what way does it end up here? So 50, have we 55 is that one. Yeah, and then it crosses over at the point where it met there. EF after the earthworks for the course have been completed. Okay, EF now is over here on the right hand side. EF's there, so our profile's over here. Now it starts at 60, so there's 5 meter vertical distances, so I'm going to measure out in 5s. Not sure how many we'll need, but that should be enough. And draw the lines. Okay, that one's 60. It's going to be going uphill for this. So 65, 70, 75, and 100. Now, each one of these points, E is on the 60 line, so E starts off here. Next one then, we can keep bringing them up. So this one is going to be the 65. 70, 75, 80. Now, what's this one on the inside? 75. Then that one is 70. So is that one. Now, it goes down. That's our crossover point. Yeah, that's the crossover point there. So I'm going to get one beyond that just to make sure it's accurate. That one there is 75, which is that one, but it changes at this point here. So I'm going to draw in that now to begin with. That portion of the mountain is not touched. It stays the same, and now that's going to be the crossover there. Then it slopes down to this point, which is at 60, which is there. So I can draw that. It's going to be a straight line. That's where they've dug out for the side of the road, or the water rafting course. And then the bottom portion then, the whole way to F, is going to be flat. So it goes straight then, because it asks for after the course has been altered. Okay, that's part B finished. Part C then, a zip line is to be constructed over the rafting course along the line EF. The zip line is to be supported by poles at point E and F. The top of the pole located in E has an altitude of 95. Okay, we'll go up to E here and we'll draw it in. 95 brings it up to there. Determine and indicate in meters the height of the support pole at point F, down here at the bottom, to provide a minimum clearance of 10 meters for the zip line from the ground. Okay, 10 meters from the ground. So the highest point is this one here. 10 meters, if I set my compass to 10 millimeters, I can draw a circle there from the very top point at 10. So the line must not hit that circle, or must not go below that circle. It can hit it, but must not go below it. So if I draw a line now from point E as a tangent to that circle, that will determine the height of the pole then at F. that there must be the height, and we can measure that. What does that work out at? About 19 millimeters. So in this case that would be 19 meters. Okay, and you've determined now the height of the pole at F, and that's that question fully complete.